Hey guys, today we're going to be learning about vertex form of a parabola. So this is what vertex form looks like. We're not going to really get too involved into this first page right here, but I do want to touch on it. Narrower, and like I said, we'll talk about it more later. That means your parabola will be skinny, and the way you can tell that is if your a value, that number out front, is a number larger than 1. And it's going to get wider. It's going to look like a fat parabola if your number is a number smaller than 1. So between 0 and 1, really. So like 0.5, 0.6, 1/3, stuff like that. Okay, in here, in parentheses with the x, if I'm adding or subtracting to the x, we'll think about the x-axis. Moves left and right. So if it's happening to the x-axis, I know it's either going to slide it left or right. Well, remember that x's are liars. So naturally, if I see a plus, I'm thinking that it's going to go forward. But since x is a liar, I know it's going to go backwards. So backwards is to the left. And if I'm subtracting from my x, subtracting naturally I would think backwards. So since x is a liar, it's going to go forward, which is to the right. It's happening at the very end. Like if I'm adding after the squared right here, if I'm adding at the end, it's going to move it up. And if I subtract at the very end, it's going to move it down. Okay, no reflection, guys. What that means is, your typical parabola opens up, like the parent function. That was ugly. Let me fix that. No reflection if that number out front, your a value, is a positive, but there will be a reflection across the x, which means your parabola will be going forever down if your a value, the number out front, is a negative. And we'll get more into this in our next lesson, but just so you have some notes on that to look back on. Okay, so my parent function, I'm going to graph it. In order to do so, I'm going to figure out my a value. I know my a value comes from the number out front. So this is 1x squared. So there's a little shortcut that I use to help us graph faster. So when your a value is 1, the way you're going to move is up 1 over 1, up 3 over 1, and I'll explain that here in a second. And then I know the vertex of my parabola is at the origin. So remember, your parent function is like home base. Okay, well, think about it. Home base is like the origin, so that's where my vertex is going to be. I'm going to zoom in. And so what we said is from this vertex, we're going to go up 1 over 1. And then from this point, I'm going to go up 3 spaces over 1. A parabola is symmetric, so what I'm going to do is what I do one way, I'm going to make it exactly the same, just the opposite way. Okay, so let me explain how I know it's up 1 over 1, up 3 over 1. Well, that's my x value, okay? Well, think about it. When x is 1, my equation was x squared. Well, 1 squared is 1. So if I move over 1 again, now my x value is at 1, 2. So I moved over 2 times. So x is 2. Well, 2 squared is 4. So what I just did is I noticed the pattern, and then using this pattern is a shortcut. So if you ever forget, guys, you can always graph and open your table and look and help you do this. But this is just a little shortcut. If you memorize, it will help you just move a lot faster. Okay, so on this one, we're going to be using my shortcut. We look for the number out front. The number out front is my a value, so a is a -2. Which is different than our home base a. So remember, a is 1 is home base. So when a is -2, it's different. So I'm not going to move up 1 over 1. So what I'm going to do is I'm going to take what it was supposed to be, up 1, so positive 1, and I'm going to multiply it by my a value. Well, 1 times -2 is a -2. So instead of going up 1, I'm going to go down 2 over 1. take what it was supposed to be. It was supposed to be up 3, so I'm going to take my positive 3 and multiply by my a, negative 2. That's going to give me a negative 6. So then it tells me to go down 6 over 1. So guys, the only thing I'm ever going to change is this first part right here. The over 1 will stay the same, okay? All right, so I'm going to go put my point on the origin. I'm going to zoom in a little bit more. And I said I'm going to go down 2 over 1. And then from there, I'm going to go down 6 over 1. So remember, a parabola is symmetric, so what I do one way, you have to do the same thing the other way. Okay, on this one, I look out front to find my a value. I know my a value is 1/2, which is different than 1, so it's not going to be home base. Well, I know home base is up 1 over 1, so I take what it's supposed to be, up 1, and I'm going to multiply by my a. 1 times 1/2 is 1/2. It's positive, so it's going to go up 1/2, which is 0.5, over 1. Okay, the next one's supposed to be up 3, so I take 3 and I multiply by 1/2. 3 times 1/2 is 1.5. I'm going to go put my point on my origin, my vertex on my origin. And we need to go up 1/2 of a square over 1. And then from there, I need to go up 1.5 squares over 1. Remember, a parabola is symmetric, so do the same way the other way. Okay, so this equation is written in vertex form. Okay, the main thing about today, guys, is in vertex form, if you can figure out what your a value is and you can figure out your vertex, I'll be happy about that. Okay, so that's the main thing takeaway I want from today. Figure out your a value, figure out your vertex. All right, so this is my equation. Notice it's different than x squared, so it's going to be different than the parent function parabola. All right, so the first thing I want to do is write down my a value. Remember, we look out front for my a value. Well, I know there's an invisible 1 out here, so I know my a value is 1. Okay, remember that's home base when a is 1. And that part that we were going to remember is up 1 over 1, up 3 over 1. We'll come back to that in a second. Okay, so now I'm going to show you how you find your vertex. Guys, a vertex is an x comma a y. All right, so for the x, if I want to find the x of my vertex, what I do is I look in my equation inside the parentheses with the x. Okay, inside the parentheses with the x, I see a positive 3. Well, we know x's are liars, so what I'm going to write down is negative 3. Okay, if I want to find the y value of my vertex, I look at the back of the equation, so behind the square, and I see if there's anything being added or subtracted. Well, since there's nothing back there, I know my y value is going to be 0. All right, so we know our a value, we know our vertex. Remember, that's the main takeaway from today. All right, so my vertex is at negative 3, 0. Okay, from our vertex, we know we have to go up 1 over 1 and then up 3 over 1. Remember to keep it symmetric. What I do one way, I do the same thing the other. Okay, so that's what it looks like. So now let's do domain. Domain is my x's, left and right. So let's put my cursor on the parabola and I slide to the left. As I slide to the left, it will go forever. When I slide to the right, it will also go forever. So there's no stopping it left and right, which means that's all real numbers. Range is up and down. Okay, well, I have my vertex right here, which is a stopping point. I have one stopping point because I see that it's going to go up forever. So when there's one stopping point, we start with our variable. We know range is y. Up forever is greater than or equal. And it goes up from the vertex, right? So I'm going to look here. Range is y, so I have to take the y value, which is the second number. So it goes up from 0. Okay, so the first thing I want to do is I want to look out front of my equation. So I know my a value is a 1. Just like home base, what we have memorized. Up 1 over 1. Up 3 over 1. Okay, to find the x of my vertex, I look in parentheses with the x. Well, notice, x is not in parentheses with any number. So that means my x value is a 0. To find my y value, I look at the back of the equation after the square. And so that tells me my y value is a negative 3. So I'm going to go put my vertex at 0, negative 3. And we said we needed to move up 1 over 1, then up 3 over 1. All right, so let's talk about domain. That's x's left and right. So as I slide to the left, it will go forever. As I slide to the right, it will go forever. That's called all real numbers. Range, I see a vertex right here, so I know that's a stopping point, and this parabola will go up forever. Okay, so I know when there's one stopping point, range, we start with our variable. Range is y. Up forever is greater than or equal to. And it goes up from my vertex, so I look at the vertex. Range is y, so I look at my y value. It goes up from negative 3. All right, so first thing I want to do is find my a value, so I look out front of my equation. So my a value is a 1. That's home base, what we have memorized. Up 1 over 1. Up 3 over 1. Okay, I need to find my vertex. So to find the x of my vertex, I look in parentheses with the x. Notice it's a minus 1. Well, x's are liars, so I know my x is going to be a positive 1. To find my y value, I look behind the square, and out behind it I see a positive 1, so that tells me my y value is also a positive 1. So my vertex is at 1, 1. And we said we needed to move up 1 over 1, up 3 over 1. Remember to make your parabola symmetric. Okay, domain, x's left and right. I slide to the left, it goes forever. I slide to the right, it goes forever. So my domain is all real numbers. Range is up and down while I have my vertex as a stopping point, and it goes up forever from there. Okay, so range is y. Up forever is greater than or equal to. And it goes up from, I look at my vertex, and I take the y, which is 1. It goes up forever from 1. All right, so the first thing I have to do is figure out my a value on this one, so I look at the number out front. Okay, this time the number out front is a negative 1. which is close to our home base over here, but it's not exactly the same, right? So we take what it was supposed to be. It was supposed to be an up 1, and what I'm going to do with this 1 is I'm going to multiply by my a value. 1 times negative 1 is a negative 1, which means I'm going to go down 1 over 1. Remember, it was supposed to be an up 3, so I take my 3 and I multiply by my a. 3 times negative 1 is a negative 3, so it's going to go down 3 over 1. Okay, so to find my vertex, to find the x, I go look in parentheses with the x. I see a plus 2. X's are liars, so I know mine is a negative 2. Then I need to find my y value, so I look at the very back of the equation after the square. Back there I see a plus 3, so I know that my y value will be a positive 3. So my vertex is at negative 2, 3. And we said this time we need to go down 1 over 1, down 3 over 1. Make your parabola symmetric. Okay, domain is x's left and right. As I slide to the left, I see it goes forever. As I slide to the right, I see it goes forever. All real numbers. Range is up and down. Well, here's my vertex, so I have a stopping point, but from there it's going to go down forever. So range is y. Down forever is less than or equal to. And it goes down from my vertex. So I look at this point. Range is y, so I take the y value, which is 3. It goes down forever from a height of 3. Okay, the first thing I need to do is I need to find my a value, so I look out front. My a value is a 2, which is different than home base. So remember, typically I'm supposed to go up 1 over 1. So I take what it's supposed to be, the 1, up 1, and I multiply by my a value. So 1 times 2 is 2. So that tells me I need to go up 2 over 1. Okay, the next one was supposed to be up 3 over 1. So I take that 3 and I multiply it by my a value, 2. 3 times 2 is a positive 6, so that tells me to go up 6 over 1. All right, so now let's find our vertex. So I know if I want to find the x, I look in parentheses with my x. Well, if I look over by the x is not in parentheses with any number, so my x value is a 0. To find my y value, I look at the very back of the equation after the square, and at the very back I see a minus 3, telling me the y value is a negative 3. So I'm going to go plot this. My vertex is at 0, negative 3. From there, we need to go up 2 over 1. And then from there, I need to go up 6 over 1. Don't forget to make it symmetric. Okay, so domain is x's, left and right. As I scroll to the left, it goes forever. As I go to the right, it goes forever. That's all real numbers. Range is up and down. Well, from my vertex, I see that it goes up forever. So y up forever is greater than or equal, and it goes up from this vertex. So I look here. The y of my vertex is negative 3, so it goes up from a height of negative 3. Okay, so to find my a value, I look out front of my equation. Out front, I see a negative 2. So I know a is negative 2, which is different than home base. So I'm not going to go up 1 over 1. So I take what it's supposed to be, up 1. So I take 1, and I multiply by my a value. So 1 times a negative 2 is negative 2. So that tells me to go down 2 over 1. Okay, next it was supposed to be up 3. So I take what it was supposed to be, 3, and I multiply by my a. 3 times a negative 2 is a negative 6. That tells me to go down 6 over 1. All right, let's find the x of my vertex. So I look in parentheses with the x. I see a minus 1. X's are liars, so I know my x is a positive 1. To find my y value of my vertex, I look at the very back of the equation after the square. At the very back, I see a plus 3. So I know my y value is a positive 3. So I'm going to go graph that. My vertex is at 1, 3. We said we need to go down 2 over 1, and then from there down 6 over 1. All right, domain is x's, left and right. So I slide to the left, it goes forever. As I slide to the right, it goes forever. Domain is all real numbers. Range is up and down. Well, I know from my vertex it goes down forever. So y down forever is less than or equal, and it goes down from this vertex. So if I'm looking at my vertex, range is y, it goes down from 3. Okay, so first, I want to figure out my a value. I'm going to show you a little trick to find your a value from a graph. It's very simple. Okay, we're going to find our a value, and then we're going to find our vertex. I'm going to put V for vertex. Okay, so here's my vertex. The x of this vertex is 0. So from the origin, it doesn't move left or right any. The y of that is 2. So my vertex is at 0, 2. Okay, the trick to find a is from your vertex, I want you to move over a single space. Okay, from this point, I want to move either up or down. Up will be positive, down will be negative. So I need to move until I'm back on my parabola. So from this point, I'm going to move up, and notice that I moved up 1 space. So that means my a value up 1 is a positive 1. Okay, the reason that we're doing this is because once I have my a value in my vertex, I can write the equation in vertex form. So this is how you do it. It's y equals, you write your a value first, you open parentheses, you write x, then you put the opposite of your x value. Well, my x value is a 0. Well, you can't really have the opposite, so it doesn't really matter. Okay, this is important. After you close your parentheses, you've got to square this guy. If you don't square it, it's no longer a parabola. And then at the very end, we put our y value. Well, my y value of my vertex is a positive 2. And from here, we know that a 1 really isn't necessary, so you could have left this off. We also know that a plus 0 is not necessary, so we could have left this off. So if this was a multiple choice problem, guys, the final answer really would have said x squared plus 2. But if you left it like this, I would understand you knew what you were talking about, and I would have accepted it. Okay, so we need to find a, and we need to find our vertex. So my vertex is here. We always start from the origin, so the x value is a positive 2, my y value is a positive 1. Okay, so remember the shortcut to find a, you put your pencil on the vertex, move over a single square. Then you have to count either up or down to get back to your parabola. Well, from here, I know I need to move down 1 space. Down 1 is a negative 1. So now I can write my equation. We always start with a, which is a negative 1. Open parentheses, x. We put the opposite of our x value of our vertex. So my x is a positive 2, so I'm going to put minus 2. Don't forget to square it. Your y of your vertex comes at the very end, so it's a positive 1. All right, so here's my vertex. My vertex is on the origin. That's at 0, 0. Okay, I'm going to zoom in so we can get a real good picture. So this one's kind of confusing. So we put our pencil on our vertex, and we slide over a single space. So from here, I need to slide up or down to get back to my parabola. Well, from here, I'm going to slide up this much, just a little bit. So slide up. I know it's positive, but how much of a square did I slide up? Well, I slid up a half of a square, which means my A is 1/2. All right, so now I can write my equation. Y equals, we always put our A value out front, open parentheses x, put the opposite of your x of your vertex. Well, it's a 0, so it doesn't matter. And then at the very end, you put the y of your vertex, which is also a 0. Okay, we know that a plus 0 is not necessary, so really, if it was a multiple choice problem, my answer would have looked like this. And your plus zeros would have dropped off. All right, so here's my vertex. So from the origin, it moved right 2, so the x value is 2. It moved up or down none, so my y value is a 0. So to find my A, I'm going to put my pencil on the vertex, slide over a single square. And then from here, I need to count either up or down. Well, I know it's up 1 square, so it's positive 1. So I go to write my equation, y equals, I put A first, open parentheses x, and then I put the opposite of the x of my vertex. So it's positive 2, so I'm going to write a minus 2. Don't forget to square it. Your y value of your vertex goes at the very end, so plus 0. So there's some things that are really unnecessary, like I don't need a plus 0 and I don't need this leading 1. So if it was multiple choice, my equation would look like y equals x minus 2 squared. All right, so here's my vertex on the origin. That's at 0, 0. I slide over a single space from my vertex, and from here I need to count either up or down. Well, it's going to go up, so it's positive, and it's going to go up 2 squares, so A is a positive 2. So to write my equation, I have y equals, you put your A value first, open parentheses x. Then you put the opposite of your x. Well, x is a 0, so it doesn't matter. Don't forget to square it. And then your y value goes at the very end. Okay, again, we know that the zeros are unnecessary. So finally, I'm going to write it as y equals 2x squared. All right, so here's my vertex. So from the origin, it went back 2, that's negative 2. And then it moved down 1, which is negative 1. So to find my A, put your pencil on the vertex, move over 1 space, and from here we need to count. I know I need to move up, and I need to move up 2 spaces. So to write my equation, y equals, we start with A, which in this case is a 2, open parentheses x. Then I look at my x value. X's are liars, so since it's a negative 2, I'm going to put a plus 2. Don't forget to square it. And my y value comes at the very end. Everything there is necessary, so that's what it looks like. There's nothing I can simplify there. That's the equation in vertex form. All right, bye, y'all.